Hello, everyone. This is an edition of the Offcut Omics video cast, where I'm going to talk a little bit about omics in general and what makes this field of science really thrive. And one of the um, fields I wanted to mention these days is something that it's not a field in itself, but it's starting to be, which is called DIY genomics or DIY omics, meaning do-it-yourself omics. What can private individuals do to do some omics investigations with some basic equipment, some basic kits? And what I've done is I started a table, which you can find up here at bit.ly/DIY omics. And this table is a compilation of different elements that you can find out there to build your own do-it-yourself omics setup. So this will point to a chart here, which is a chart of prices, and it's got two columns, the kit column and the unit column. And the main motivation for creating this table has been one of the announcements from Oxford Nanopore, the Flongle device from Oxford Nanopore, which is a device that allows you to do some sequencing from a very small footprint device. And the sequencing that you can do is quite powerful these days, and it allows you to do quite a lot of sequencing without having to spend a lot of money per unit of sequencing experiment, if you want. So the unit price is listed here at about $110. You have to buy a starter pack that will put you, set you back at about $5,250, but that gives you a lot for that price. You can have a lot of small experiment units you can do for that. In comparison to that, the, let's say, nearest competitor in the field of do-it-yourself omics would be the Illumina iSeq 100, and you can buy a pack of 4 reagents from Illumina. That will mean every kit, every cartridge that you use will be priced around a little bit over $600, so much more expensive in comparison to the unit price of the Flongle. And you can buy a kit of 4 for about $2,500. Further along, if you want to do more experiments, higher throughput experiments, and then probably there's going to be a point when it's not do-it-yourself omics anymore, it's more like proper science, then the mean ions, if you buy enough flow cells, each experiment is going to be still sub $1,000, but around $800 or $900. So what else do you need to do something useful in your DIY omics experiments? You're definitely going to need some compute. You're not going to have to do something with the data that comes out of the sequencer. And for that, you can buy computing units from Nanopore itself, the company. They have this MinIT or Minute mini computer without a screen that is at $2,400 at the moment. And then you can supplement that compute by your own laptop or by adding some other elements here that will make your DIY more compact, more portable, and with more possibilities for integration. I've listed here the Kano Computer Kit Touch, which if you put together and spend hundreds of hours on this or thousands of hours on this, you're going to end up replicating what Nanopore themselves, probably to some extent, replicating what they sell recently in another kind of touchpad computer of this kind. And then here I've pointed to some other cheap editions that you can have. This Coral Dead board from Google, which got one of these TPUs for doing deep neural networks, 150. The equivalent from Intel, they're pitching these a lot for computer vision things like this, putting it on drones, etc. But to be honest, you can use it for whatever you want. And NVIDIA Jetson Nano also, people have been doing their own DIY, putting this on drones and trying to sort of do image recognition of a drone flying around. But all of these are very powerful kits of equipment that, as you can see, they're about $100 to $200 each. In terms of integration, like physical integration between something happening and you wanting to control it by a computer, I've listed here a couple of the well-known ones. The Arduino starter kit, $100, and the Raspberry Pi, which in itself is just a computer, but if you add the other elements that you can buy that are compatible with it, it allows you to do some integration. And finally, what comes actually first, which is the sample prep. Nanopore themselves, the company, sells you the Voltrax, which in its kit, it's about a bit over 8K, but each unit, if you don't count that this comes with actually sequencing reagents needs that you do that need for sequencing itself, each sample prep unit is about $500. Googling out there, I also found out about OpenDrop. And OpenDrop is a way of controlling drops of water via electrowetting, and it allows you to do some DIY sample prep. It's not going to be as sophisticated as the sample prep that you can do if you buy a big instrument from Hamilton or other providers. That's the size of a big refrigerator, but it's a starting point for people wanting to experiment with sample prep. So as you can see, this is the DIY Omics table. I've charted it out here, and you can click on the links and find out more about, for example, what OpenDrop does and doesn't do. And I'm looking forward to extend this table. So if you have any recommendations, send me a tweet. I'm on Twitter, and my Twitter handle is my name and surname, Albert Vilella, all one word. And so you can recommend me. What else could I be adding to this DIY Omics to make it more complete and reflective of what's happening out there? Thank you very much. I'll see you in the next The Offcuts Omics videocast.